Rain falls from the sky. It lands on mountains, fills rivers, and eventually flows into the ocean. Fresh water the entire way. Rain is fresh. Rivers are fresh. Always. So if everything feeding the ocean has always been fresh water, why is the ocean salty? Where did the salt actually come from in the first place? The answer goes much deeper than anyone expects. Here is the problem. Water cycles. Rain falls, fills rivers, rivers reach the ocean, water evaporates, rain falls again. The same water going around and around forever. If that cycle keeps bringing fresh water into the ocean, why has billions of years of fresh water not diluted the salt away? Why is the ocean not getting fresher over time? The ocean has been receiving fresh water for 4 billion years. It is not getting fresher. The salinity has stayed relatively stable for hundreds of millions of years. Something is keeping it there. Salt enters the ocean from 3 separate sources. The first source is rain. Rainwater is slightly acidic, not because of pollution, but because water vapor absorbs carbon dioxide in the atmosphere, forming a weak acid. When that acidic rain hits rocks, it slowly dissolves minerals out of them. Sodium, calcium, magnesium, all pulled from the rock and carried away by rivers toward the sea. Rivers do carry dissolved salt, but the concentration is so low, around 0.01%, that river water tastes completely fresh. The salt is there, it is just invisible at that scale. But rivers have been delivering those invisible dissolved minerals to the ocean without stopping for 4 billion years. A tiny amount per river, multiplied by every river on Earth, multiplied by billions of years. Scale changes everything. If every grain of salt were pulled from the ocean and spread across all land on Earth, it would form a solid layer 166 meters thick. That's roughly a 40-story building covering every continent, every mountain, every desert. Salt goes in through rivers, but the question remains, why does it not come back out? This is where the ocean behaves differently from everything else on Earth. When ocean water evaporates, only the water molecules leave. Everything dissolved, every mineral, every ion of sodium and chloride stays behind. Evaporation is a purification process, for the water, not for the salt. Water cycles out, salt does not, ever. This is the foundation of why the ocean is salty. Water in, water out, salt in, but never fully out. Over millions of years, that one-way accumulation built up into the saltiest body of water on Earth. Sodium and chloride, ordinary table salt, make up 85% of everything dissolved in the ocean, not because they are added in the largest quantities, but because they stay the longest once they arrive. Sodium has a residence time of 260 million years. Once a sodium ion enters the ocean, it stays there for an average of 260 million years before being removed. Chloride stays even longer. That is why they dominate. But rivers are only the first source. There is a second one. In 1977, a deep-sea research expedition near the Galapagos Islands sent equipment to the ocean floor. What they found there completely changed how scientists understood where ocean salt actually comes from. Along the ocean floor, where tectonic plates pull apart, seawater seeps down through cracks and contacts superheated rock far below. That water heats to over 400 degrees Celsius. Then it shoots back up, loaded with dissolved minerals. Scientists call them hydrothermal vents. Before 1977, nobody knew they existed. The discovery revealed a second system pumping dissolved minerals into the ocean from beneath the ocean floor itself. The entire volume of ocean water cycles through these hydrothermal systems roughly once every 10 million years. Over geological time, that process has added an enormous amount of dissolved material to the sea. The vents add minerals, but they also remove some. And there is still a third source nobody talks about. There are an estimated 1 million underwater volcanoes on the ocean floor. Many of them are active right now. When they erupt, they release gases and minerals directly into into the surrounding water. One of the key substances released is chloride, one of the primary components of table salt. Underwater volcanic activity has been supplying chloride to the ocean throughout Earth's entire history, without pause. 3 separate systems: rivers carrying dissolved rock minerals, hydrothermal vents cycling seawater through superheated rock, underwater volcanoes releasing minerals directly, all feeding the ocean simultaneously for billions of years. Want to see what happens with no regulation? The Dead Sea has no outlet. Water flows in, only evaporation takes it out. Salt never leaves. The result is 34% salinity, nearly 10 times higher than the open ocean. The body floats without any effort whatsoever. Ocean salinity is not just a geological fact. Saltier water is denser than fresher water. That density difference drives the global system of deep ocean currents that moves heat around the entire planet. Without it, entire continents would be dramatically colder. The ocean is salty because rain dissolves rock and rivers carry it in, because evaporation traps everything dissolved inside, because hydrothermal vents add minerals from below, because underwater volcanoes never stop. The ocean has no drain, and that changes everything. Next time you stand at the ocean and taste the salt on your lips, you are tasting 4 billion years of rain-dissolving rock, rivers carrying it in, and evaporation locking it there permanently. Subscribe to Simple Things Hidden Truths. New hidden truth every day.